Okay. So, first thing is looking at those, because you are going to have to, in order to know how you're going to be naming them, you're going to have to be able to determine whether you have that covalent or ionic bond, because that'll be the best way to kind of chunk it if you're not going to be using that flowchart, right? So looking at these, what is going to be the one indicator that we've got that'll tell us that we have an ionic bond? What's the question that you're asking yourself? Is there a metal? Yep. Okay. Once we've determined that there are metals in all three of these, we know that they're ionic bonding. We know that they're going to be named kind of similarly. Okay. What's the next question that you would ask yourself? So even just looking at the first one, we have. Yes. And if you just want to write down words, you can. The main words. Okay, so is there a transition metal? If there is, then what would we have to do? Got to figure out the charge, okay? You're going to need Roman numerals, so that'll be the one that we will have to kind of figure it out. And I'll run through it one more time today before we keep going, okay? And then we would ask ourselves, what else? So once we've, yeah, is there a polyatomic? And are polyatomics really that difficult when it comes to naming them? No, it's matching it up, right? We got our periodic table full of this list. Today I'm gonna tell you guys that I have a pile of other ones that are not on your list that you're more than welcome to use when we start doing the practice, because I think there's a couple that go beyond your list, and so you can always refer to this. This is a bunch of them, and it's all of your transition metals. But don't cheat. You guys still do the math for it. All right. So is there a polyatomic? And if there is, you just look at your periodic table and write it, right? So nothing difficult here. It'll get a little challenging when we start writing the actual formulas, because you are going to have to pay attention then to the charges. Right now, we don't really care too much about the charges unless we have a transition metal, right? So those are going to be the questions that we're going to ask ourselves as we're looking at these three examples. So I'm just going to kind of shrink this, put this up here, this right center. Okay, so for our first example, we've got SRBR2, and hopefully you have a periodic table right in front of you, because it's going to be really hard to figure this out if you don't have one. So I'll give you a second. So we look for, first of all, we're asking ourselves, is there a metal? So is there something that is on the left-hand side of the periodic table? Yes, right? We have, sorry. All right, so we have our SR. Is it a transition metal? Is it in the center or underneath the metalloids line? No. So do we need to worry about doing anything fancy for this one? No. So let's go ahead and write out the first thing. So we're just going to write out who the metal is. So who is SR? Strontium. What kind of metal is it? Alkaline earth. Good. Okay. So we have strontium. Now we're going to that third question. Is there a polyatomic? Is there, and what are we actually looking for? I should have added that to our little question. What are we looking for usually for those polyatomics? Okay, so we're looking for some oxygens, all right? So are there any oxygens attached to that little second thing listed? No. So no polyatomics, so we're just going to name it as is. So that one is, who's Br? Bromine. But what do we do to bromine to make it correct? What do we have to end it with?
2.
No. Is it strontium bromine? Doesn't that sound weird?
Bromide.
Bromide. There we go. All right. So we're going to take off that last little ending. We're going to add "ide." Okay? So that's our other key. Did you say it? Sorry. Say it louder. All right. So don't forget, ides are usually how we're ending, unless you got a polyatomic, then you're just listing it, right? All right, so we have strontium, bromide. All right, and we're gonna actually come back to that one, so leave yourself just a tiny bit of space next to it. You don't need a lot of space, but just a tiny bit, because I do wanna show you something with that one, okay? All right, so moving on to the next one. We have Rb3PO4. So, is there a metal? Is it ionic? Yes, who's the metal in there? Rubidium. Okay, so we have Rb. All right, is it a transition metal? No, it's an alkali metal. Good. All right, so we're going to go ahead and write him out first because we're done analyzing the metal. Rubidium. Okay, don't really worry about that 3. Nothing changes with that. Okay, and then we ask ourselves, is there oxygens attached to something? Yeah. Okay, and what did I kind of tell you when you guys were first learning about the polyatomics to do with your polyatomics to help you with the next few chapters, probably till the end of the year? Bet. Do you guys remember? Start practicing whenever you see a polyatomic, put parentheses around it so that you leave it together. You want that thing to stay together because it is acting all together as an ion. So they're all like bonded pretty permanently. That's not really true, but they're bonded pretty tight, and then they happen to have a charge, and that's the only reason why this metal comes in and attaches to it, okay? All right, so we have PO4. So what are we going to do since we have a polyatomic? Look at your periodic table. So everybody look at your periodic table. Find it. It should be phosphate. Is that what you guys found? Okay. What did you say, Jay? You sure? Okay. All right. So, rubidium phosphate. Any questions here? Okay. Let's go to the next one. Now we have Ni3N2. Ni3N2. So, is there a metal in this? Is there something on the left-hand side of the metalloid sign? Yes. Okay, so it is definitely ionic. So we know we're possibly going to end in either a polyatomic ion or we're going to end in ide. That's the big thing right here. Okay? All right, and then is there a transition metal? Heck yeah. So I'm going to kind of zoom in so that we can really focus on. No, I'm not. I'm going to move him. All right, I just need more space. All right, so we have Ni3N2. So once we have a transition metal, do we know the charge on that transition metal? Because we know we got to add Roman numerals eventually, right? So do we know the charge on nickel? No, right? Who are we going to rely on? Which one of those charges do we know? Nitrogen. Look at where nitrogen is located on your periodic table. It is in group 15. So how far away is it from a noble gas? How many spaces? 3. Little bumps, right? So 3. So we know nitrogen happens to have a -3 charge, right? No, I didn't write it there last time, did I? Actually, I guess we could. All right, so we're going to focus in on just nitrogen. He has a -3 charge, right? So that -3, how many nitrogens are there total?
2.
There are 2. Do you guys see that? Do you know where she got that number? The little number to the left, to the right? Okay, so since there are 2 of them, what is that overall negative charge? A -6. Okay. Things bond so that they are stable, so that they have this full outer shell, so they have 8. What is the charge when I have 8 valence electrons? What is the charge on me? 0. Okay, so stability is having that charge of 0. You have no need to move or send electrons away. Okay, so totally we need to have this whole compound equal 0. So what is the missing number right here? A 6, a +6, correct? Okay. How many nickels are providing that +6? 3 things, right? So we're going to take that 6 and divide it by 3 to get us what number? 2. A +2. That's the charge. So once we figured that out, okay, so I kind of made it not so U-y so you guys can actually see a process there. Hopefully that helped. But once we have that charge, now how do we name it? Now it's easy. What is it? Nickel. I was going to put LE. All right, Roman numeral 2. How do we end the last part? This is a tough one. There's a lot of letters here. Because we know it's nitrogen, right? I'm off my screen. Okay, so it's nitrogen. We're going to take this part off, or we're going to add "ide." So it should be nickel 2 nitride. How do we feel? We okay? Okay. All right, so once we had strontium bromide, okay, the next challenging thing is taking words and putting them into those funny formulas, right? So you already know what the formula is, but I want you to see the drawing part because you are going to have to be able to draw all these compounds. And ionic, it's easy, it takes up space. The molecular ones are going to be a piece of cake. You'll have no problems there, okay? But for strontium bromide, what we're going to do is we're going to start with Lewis dot structures. So strontium, you guys told me he was in what group? 2. So how many valence electrons does strontium have? 2. So we're going to draw 2 Lewis dot structures, or 2 little dots for its valence electrons. And remember, we don't double them up, we spread them out and then fill them up, right? So we have strontium, and then bromine, Br. What does bromine have? He's in group 17. 7. So we're going to go 1, 2, 3, 4, 5, 6, 7. Okay? So kind of like what we did in our notes for that one example with potassium and sulfur, we look at this and what is their ultimate goal? Why are these guys bonding in the first place? Because they need to have 8, right? So from our notes last time, what did we tell ourselves? We said that strontium, it's easier for it to lose them than it would be for it to gain them, right? Because he would have to gain 6 right there, and that's crazy. He could just get rid of 2 and then he's done, okay? So looking at this, when you go to draw these things, what you're going to be doing is you're going to be putting these guys in little brackets, kind of like that, okay? And this is the conventional way, so you do have to use the brackets when you are showing an ionic bond happening, okay? And so this little diagram is very similar to what we did with the arrows, all right? So what did we do in our notes? Do you remember? We're showing him giving that electron, right? So if we draw an arrow like that, we're showing that he's donating that one. But what do we know is the problem? Is strontium okay? No, strontium needs another bromine. So we're going to draw one more bromine right below it. Just copy your dots one more time. This is that time-consuming part. Okay? And now we're going to show that electron gets donated there. So you're just telling someone looking at your diagram where those electrons are going. Okay? Once you do that, this is the time-consuming part, you got to draw another set of this, and you have to show what you actually have. So looking at this, now you're going to have an after picture, and you're going to have strontium, who doesn't have any valence electrons now, because he just donated 2 of them. So what kind of charge does he now have? Oh, I see what you're saying. No. Good. All right, so we're just going to put a little +2 right here, and that's how you actually draw out ions, okay? You have to put them in brackets, show that they either lost or they gained those electrons and give them their charge. So that means our 2 bromines, we're going to draw those right next to it, How many electrons do those guys have all the way around? They're now going to have 8 each, right? So we have 1, 2, 3, 4, 5, 6, 7, 8. Okay, since bromine gained an electron, what's its charge? A -1. And the other bromine is also a -1. Okay? So if I were to ask you to show me strontium bromide drawn out, this is everything you actually have to include. You have to show the transfer and the after picture. It's annoying, right? Just a little bit. But the cool thing about this is looking at this, what did that just give you? What does that match up to? Think about the subscripts. Look right above it. How many strontiums are in the little formula? Should just be SR and then BR2. That's where that's coming from. And that's how you're going to be doing your formulas. Okay? There is a shortcut, but you got to do this way first, and then I'll show you a shortcut tomorrow. And some of you guys, if you already watched a video, you already know what the shortcut is. Good job. You got to do this. Suffer a little bit. Okay. All right. So is there any questions on what I'm expecting of you to draw? Did you guys get these copied in at least? Okay. One thing that I probably will never ask, at least for a while, is I'm not going to have you draw something with the phosphate. That requires a little bit more than just these things, but you can draw phosphate in the same little brackets, put the little charge, and you'll see the same thing happen. But I will never ask you guys that, okay? I will also probably never ask you for a transition metal. So this is just for your binary compounds, the easy ones that are just straightforward naming, okay? Is that cool? Awesome. All right. So what I'd like us to do is use this for just about 10 minutes, okay? I'm going to hand out a paper. It is a class set. I did not have my little page protectors. If I find them, I will pass them out. But don't write on it. Write on your piece of paper in your journal for practice, okay? We're all good? And then I'll show you molecular before you leave today so that you're good to go with that one. And we can start drawing that one tomorrow, okay? Okay.